Hello and welcome to another tutorial. So this time we are going to be continuing to build on the Sims-style AI project. So we're going to make some improvements and robustness changes there to it, but the big focus that we're going to be looking at in this one is adding a bit more of a sense of personality to the Sims. So making it that, because everyone's reactions to the different things that might happen is different. One person reading a book is going to have a different effect to another. So we want to actually be able to capture that and have our Sims be able to react differently, and also be able to have different reactions there for just their general way that things might change. Like ones might get hungry faster or might get bored faster. So those are the kinds of things we're going to be factoring in. So let's dive on in. First thing I want to do is there's a couple of improvements and changes I want to make things a little bit more robust with how it works with the performers. And thank you to Seriphis for flagging a couple of suggestions for improvements and things that can be updated with this. So what I want to update is some stuff centered around how the performers and things like that are tracked in the actual setup. So at the moment, with the performers, we've got a little bit of double handling where we're using num-current users, and we also have stuff directly going into a list. Now, part of the reason for that separation is an AI locks an interaction when it selects it, not when it actually starts to perform it. So this allows it to lock it early, but if it doesn't actually finish using it, then it could result in it not being unlocked. So there's potential issues that could happen there. So I'm actually going to change this. So num-current users, I'm going to change this to something that just maps to current performers count. And well, it doesn't need to be. I'm going to move it down like that. Now, that immediately is then going to cause a couple of sort of flow-on issues, which is good. That's the intent behind it. Because I actually want to make a fairly large change to how I work with the performers. So I'm going to change this so that the performers is stored as a dictionary. And we use the performing AI as a key and performer info as the value. That's just going to make it really easy for looking up the particular entries. And that'll actually mean, so performing AI becomes common AI base. So what that will mean is it actually is a lot easier with this. We don't have the same amount of information. So then that's going to change stuff like locking. Well, a particular AI has to actually lock the particular one. And what this would allow us to do then is we can go and check and see, okay, well, if the number of current users exceeds that, then we're not going to be able to lock it. So it'd be good for lock interaction to be able to return a bool indicating that there's a problem. Again, this gives the AI more information. We want to keep that error. This would become if it's greater than or equal to. So that's good. We won't be able to lock it if it's a problem. By default, we would return true. And what this would mean is when we lock it, we would actually go current performer, and this is where we've got a couple of ways we could go about approaching this. So because there's additional information here that we're only going to be populating when it's actually performing it. So what I would do is, there's two ways. I could go with assuming that, okay, if it's null, then it's been locked but has not started performing. Or I could add in a Boolean here for tracking the fact that it started performing it or not. There's no real sort of major advantage for either approach at this stage. So when you have a scenario like this where at the moment we don't have a compelling reason for either approach, what I would generally do is we'll keep it simple. So that's good. Now we've got a bit more information at this point, so we could actually check if the same character is trying to lock the same interaction. So I could actually go and check, well, if current performers already contains that key, I'm going to return false because we can't lock it a second time, and we don't want to lock it a second time. But I'm also going to report that error. So big believer in things like this, making sure we're logging out errors, because these are things that are invalid. So set up errors for them early on, because that way then during development, if something happens, we get an immediate notification for it. Don't wait till there's a bug to add in things like error checking for it. Always make sure you're doing that error checking and reporting early. It means that you find the problems as soon as they happen generally, not potentially weeks, months down the track, which can be, makes it that much harder to try and find them. So in this case, I would say performer.name tried to lock. I can put out the display name multiple times. So that's good. Now the num simultaneous, I think still want to keep that as a log error, because that what I would do is also indicate performer.name trying to lock display name, which is already at max users, because that's something that, again, AIs should be using can perform to check if they can lock it. They should be doing that before they try and actually lock the interaction. So it's something that this indicates likely that code has ignored that limit. So that's good. Now, base interaction, we're going to have to go and update this so that lock interaction returns a bool and has the common AI base. So we're going to add that in. I'm going to do the same for unlocking. So we're going to make it that we've got a bit more robustness on both sides for it. So that looks good for the locking of the interaction. So num current users, we can change this so that it actually becomes if current performers, and we can do a contains key of performer, and this would actually go to being if it does not contain it. So we can say performer.name is trying to perform an interaction, and we log out the name, that they have not locked. And again, I'm going to make it that this returns a Boolean, just so we've got a bit more information coming back. So this allows then the AI to be able to manage and handle those errors a bit if it needs to. So that looks good. Checks if it's there. Then we're checking things like the stats. Now when it goes to perform, we can see that this is where we can set current performers. Performer is a new, and we just put in the performer info. We don't need to set the performing AI anymore because that's something that we've already got populated. So that's good. We've set up our performer info, and then in this case, we would return true. Now, we've got a couple of things we potentially need to handle here with stuff being completed. So what I would do is have on interaction completed, and this needs to potentially have our performer. So we give it the performer, and we give it the on completed handler. And we'll set up here, this will be a protected void on interaction completed, takes a common AI base, and then it also takes that unity action with the base interaction parameter, and then we move this down to here. Now there'll be some further things we need to do, but this is the starting point. So that's good. Unlock interaction also has the performer get passed through. Now what we would check is if the current performers contains the key, then that's actually really straightforward. We remove it and we return true because it's completely valid at that point. If it didn't contain it, then now we can actually log out an error and we'll return false. So we can say performer name is trying to unlock an already unlocked interaction. Or to unlock an interaction they have not locked. So that's good. Now our update changes a little bit, the way we have to loop over things here. We now have for each var KVP, so key value pair, in current performers. Because then what I'm going to do is just rename performer here to performer info. That just makes it a little bit cleaner and easier for when I go performer base and we do performer. So that is going to be our key value pair.key, whereas this is KVP value. So when we're iterating over a dictionary, we can iterate over just the key value pairs, is something I find I often end up doing. This changes to performer. That just cleans everything up a little bit. Now on completed, this again, I'm going to change that to on interaction completed, pass in the performer, and we pass in the performer info dot on completed. So that's good. That should make this a bit more robust with working with that. Now, one other thing that is a possibility that could happen is something could fail to lock the interaction, or in its on completed handler, something could unlock the interaction, which if we go and unlock an interaction while we are looping over this, so say something completes, runs the onCompleted handler, it unlocks it, that would modify this collection. And something like a dictionary list, any of the collections, if you are looping over them using a for each, you can't modify that collection during that loop. It will actually cause issues. And that's okay. Because a common thing that we end up needing to do is we need a delayed removal, essentially. So what I would be doing is I'm going to have a list, so common AI base, and this is going to be performers to clean up. And the idea is going to be that when we go to unlock an interaction, we're going to say, okay, well, performers to clean up, we're going to add that performer. And then in on interaction completed, it will invoke the onComplete handler. But what we'll do is we'll do a check here. And we're going to say if performers to clean up does not contain performer, then we're going to add it because that means it's failed to actually do that. But what I'm also going to do is I'm going to log out, in this case, I would log out a warning. Because this is something where we want the onComplete handler to flag something as unlocked. And if it doesn't, we'll safely handle it, but we'll flag it up as a thing to be addressed. So it's, I think, a reasonable use of a warning. So it's not something that's going to be a problem because we're handling it. If we weren't handling it, then I would change it to a log error. So it'd say performer.name did not unlock interaction in their onCompleted handler. And we just log out the display name just in case we need it. So now I have this list of performers to clean up, which I'm going to bring this list up to the top and just keep track of it here. We'll mark that as protected. Could be inheriting from this, might be a useful thing. So we've got this list of things now to clean up. So the safest point for us to clean these up is actually here in update. So I can go and loop through var performer in performers to clean up, and we do current performers remove that particular one, and then at the end of that I would do a current performers clear. So clean up any performers that are finished. So that is a common scenario that we'll see, something where we might be looping over a dictionary, things like that, and then we do a delayed cleanup. So in this case, most interactions, the completion will happen at this point, so then they get cleaned up. So that looks good. So let's test this out. Let's see, have we missed anything? Have we broken anything? So we do have a change here for this, which is to be expected. We had a couple of things that were going to be changing, so that's good. And then a couple of other ones that we'll find need to change. So things where we are locking the interaction has to change. So our simple AI, when we're unlocking, also needs to change. And our not so simple one, when it locks, also needs to change. So part of the reason for changing the things in the way that I generally do is so that it will actually provoke compiler errors as a way of making it easy to track down things that we need to fix. So now we can see we do have a couple of exceptions happening. So we take a look in the update. So this is failing to find the performer info. So that means for something like if that to happen, and we can see that's happening from the very beginning. So it means it's trying to update when the performer info is not populated. And that makes sense, because performer info doesn't get set until we get to the point where the AI is there and starting to perform it. So that's an easy one, where what I do is I check if performer info is equal to null, continue. So that's something where if we'd gone for a Boolean in the performer info of saying has it started being performed, or even potentially an enumeration, we could be checking that there. So now when we run, they go to their respective objects. Now we can see they tried to perform something that they hadn't actually locked. So it's checking if it contains that key. So that's actually really good. We want to know that that's happening so that we can actually then figure out why that particular error is happening. So this is something where we can attach to it and then we can run it, because we should see that appear up when we go to run it. So this should go. Now we can see the current performers is empty. But if we go to our not so simple AI, it should have locked the object. So that tells us that there's likely something happening with the locking of the interaction that's potentially causing issues. So we're going to add in a breakpoint where we go to lock an interaction, and we're going to just stop things, and then we'll restart again. And this is why we put in those errors, because it was still heading over to it, and we might not have necessarily spotted the problem if we hadn't done anything about it. So it goes, it's adding in the current performers. So now current performers is 1, which is good. Now we do have a code that cleans up the current performers, and we can see we made a typo down here. And this is a thing where autocomplete is something that can easily introduce bugs. We were doing that. So we needed to make sure we're clearing the correct thing. So something to always watch out for. I do find autocomplete is one of the major causes at times for bugs. Because now the AIs head over there, they go and run and perform the particular thing. So they're still there doing their particular ones. Now they're able to be heading over and doing different things. So there's been an interchange there. One's locked and then another one's unlocked. So that's good. We've got our AIs going through that updated setup, which is good. Now we want to give our AIs a bit more of a personality. Because if we look at, say, the microwave, the interactions there, they add energy. If we look at our AIs in terms of their sort of stats, they have decay rates, things like of that. What I want to be able to do is have it that the impact of the scoring, which we do the scoring over here in our not so simple AI, when it goes and it tries to score things, it asks for the particular sort of effect of it. So that's doing a little bit of scoring there, and it knows the particular stat. I want the AIs to be able to interpret that differently, because the way they do it is they score an interaction, which if we go to score interaction, it goes through every stat change and that determines it. So what I want it to be is something where an AI could say, okay, well, this object adds to my fun. And an AI might have that be something that has a larger effect, or it might have a smaller effect. And so this is going to give us a bit more control over how the AIs actually behave, which will be great. So, okay, we've got a few different areas of where we could be adding that in. So the common AI base does have a bunch of key stats for that. But what I eventually want to be able to do with this is I want to actually have scriptable objects drive this. I want to be able to give the AIs essentially traits. And those traits are what affect how everything gets scored. So what I'm going to do is I'm going to create a folder here for traits. And then I'm going to set up a folder for scripts. And we'll also set up a folder for data. And I'm going to create a scriptable object, and we're just going to call this trait. So a trait, we want to change that to be scriptable object. We want to set up our create asset menu, which menu name, we're going to make that AI trait. And we can set the file name, which would default to trait. So we can get rid of our start and update. So a trait, we want to have it be able to, similar to what the interactions do. So if we look at the interactions, they have this stat change. So the question becomes, do we want a trait to be able to affect multiple stats? And I think yes. I think that makes sense for them to be able to affect multiple. So we actually want a very similar setup to this. So what I would do is there's a couple of ways we could go about approaching it. We could have something that for the trait, I'm actually going to have it be a little bit different. So we're going to have this be called trait element. So it'll have a particular stat. And I'm going to have one for if it's a positive value. So one for if we're benefiting that stat, and we want different scale for if we're having a negative impact on it. And these are going to be ranged values as well. So I want these to go from -1. Actually, we're going to go from trying to think of a good range, I think 0.5 to 1.5. So the idea being we can either have it that it minimizes it or it increases it. So positive scale and our negative scale. So you could have different values here. So you could have something where a character might react very strongly to something that adds fun, but they also don't. You could have them react very strongly to something that reduces fun, or you could have them basically it has less of an impact. So they're really affected by a positive side of things, but less affected by negative. So that'll be something we'll be able to set up with this. So we can then have a public list, which actually this can just be an array. So public trait element, and we just have the impacts, which is largely what this is. This is going to be the impacts of the particular thing. It would be useful to have a display name. So we're going to give this a display name as well. There might also end up being things like you might have icons, stuff like of that. You might have a longer description for it as well. So there's different things that we could be having there. So these are things that are going to be affecting the scoring. So we could have these scoring factors. And we could also have something that affects our ambient decay rate, because if we remember with this, we had a base decay rate. So we could have a separate one that affects the decay rate. So this, again, we want to have the ability to increase it or decrease it, and I think 50% either way is more than enough range. Public float decay rate scale. And what we'll do is our common AI base, we're going to give it a header, and we're going to give it our traits. Now, I'm going to end up making this protected because I think it's something that it might be useful. I will have this one as a list because it might be something that we change over time. So we'll have that be traits. So that's good. I'm just going to give these some default values as well, and just have it that the default value is at that midpoint, whereas effectively that will mean that it's doing nothing. So then what I'm going to do is I'm going to create a new trait, and then if I select that trait, can add in ones. Now it hasn't properly populated that, so that might be a bit of a bug with Unity. So in the middle means that it's not going to make any impact on it. Now what we could do is let's have something that for energy, maybe they gain a lot more energy, and maybe then things that decrease it actually have less of an impact. And the scale rate here, that might be something that we leave that at about the same. So this could be something where it could be easily energized. Go with that as the name for it. We could also have another one that it might be easily entertained. So they're one that rather than affecting energy, it affects fun in a similar way. We could chuck in one where they might get easily bored. So in that case, for easily bored, what they would do is it's going to affect fun, and positives will have a little bit of an impact, but negatives will have a big impact. So they will get bored much faster. And so we've got a couple of traits there. Entertained. So what I'm going to do is I'm going to say this one, they are easily energized and easily entertained, whereas the other one here is just going to be easily bored. So that's good. We've got our traits in there. Now we need to have them having an effect. So, okay, let's look through where we're using things. So the decay rate is going to be one that we do need to have this apply to, and it factored that in. So if we take a look and see where we're updating the decay rates, we're doing that down here in our update. So we need to run these changes through those traits. So, okay, I need a thing that's going to go protected float, apply traits to, and we can give it the particular stat. We can then also give it the base value. So that's good. So what I would then return, and I can actually I'm going to call that current value. So then I go through and I loop through every trait. So every trait in our traits. And then the easiest way to do this and how I would generally do it is say, okay, current value is trait dot apply. And we give it again the stat and the current value. And I'm actually going to copy this because it's going to be very similar. So come down here, and this becomes apply. This becomes public. And we're looping through the impacts. So we go impact. And again, I could have it that it goes to that trait element class. So we just defer everything to the point where it's able to be directly doing the calculation. This is generally how I like structuring code like this. I find that it minimizes the amount of changes I need to make later on if I'm needing to modify or extend things, because it's all contained in the one spot. So cool, we've got that. So what I would do in this case is firstly, well, fstat, which I'm going to change that to target stat. I think will be just avoid potential sort of overlaps there with it. So I'm going to change that to target stat, which does mean a few updates throughout. So if target stat is equal to stat, then we need to look at with this in terms of, okay, well, for this sort of setup, we want to check, okay, if the current value is greater than 0, then we would do current value multiplied by the positive scale. So it's something where it's increasing it, so we apply the positive scale. Otherwise, if current value is negative, then unsurprisingly, we multiply by the negative scale. So that's good. We haven't factored in the stuff with the decay rate though, because these are positive and negative scales. How do we know if we're working with decay rate? So with this, we would check is decay. So we're going to feed that through as well. We'll make it that what we can then do is here we check, okay, well, if it's decay, then we do current value multiplied by that. Otherwise, we know it must be something where we've got the positive and negative scale. And this is where I say it makes it easier for later on if I wanted to split this so I had positive and negatives for, stuff like decay rate, things like that, or other thresholds. That change only happens in here. So if I need more complexity to how those trait elements scale things, it's isolated to one class and one function in a class, really. So it makes that process much, much easier to actually work with. So then in our common AI base, what we need here to also be passing through efforts decay. And then down here gets quite straightforward. What I would do is apply traits to, we say estat fun base fun decay rate. So where we previously used this now becomes that. And we do a similar thing for energy. That is going to give us the results we need, and we say that yes, this is for decay. So now our ambient decay rate is going to be affected by whatever traits we've attached onto the character. So that's great. Now we can start doing the actual sort of things like scoring, but we also want to make it that this updating individual stat, because if we want to take a look and see how is that being used. So we can see that gets applied here when it does the apply stat changes. So we would do a similar thing with that, where we would be saying, okay, apply traits to. We can just actually go target, amount, and false. So that makes it really easy. And what I would probably do is go, okay, adjusted amount is that. Then we just are adding in the adjusted amount, which is good. So now we've got those changing. Now we don't have anything that is clamping these, so I would actually change this. So in both of these cases, I'm doing a mathf clamp 01. We just do current energy and current fund plus the amount. So there's just a plus. This just ensures they don't inadvertently, like an update would immediately correct it, but it just avoids it getting an incorrect value in there at any point. So that's good. Now the systems, they'll have more of an effect. So it's just now on the scoring. And again, we could have things affect the scoring differently to how they affect the actual stats, but changing the particular setup here, if we look, we've got scoring of a change. So when we go to score a change, well, this is looking very, very similar to sort of the previous stuff where we were grabbing the amount here. So what I would do is I can go apply traits to, and we're saying what stat it's targeting, and it's not decay. So now the way the AIs score this is going to be based upon what that adjusted impact is going to be. We've adjusted our scoring here, so we're pretty much ready to test because we've got these. This will change the scoring. We've also gone and updated how it actually changes the individual stats. One thing just spotted here though is we need to make sure we're assigning that back. Otherwise, that would have resulted in them never gaining anything from doing any of the interactions, which would be very, very bad. So let's run this, and what we should see is, if you remember this first one's the one over on the left here, they currently have no traits, so we're going to set up so they have easily bored. And this other one, we're going to make them easily energized and easily entertained. We'll just save those. So we've added the traits in. This is the thing that makes it really easy for adding in particular traits to a character. And it could happen at runtime, which is great. So we can just drag on the particular traits. So we're looking at the easily bored one. And what we should notice is their fun rockets up because something that's entertaining, they really, really want to do. So it's just rocketing up the fun there for them. And so that is building up much faster than it would for any of the other characters. So now that that's happened, they're going to probably tend to want to keep doing that because they're very easily bored. So they're prioritizing that over actually getting food. Now food has had to get such a low level that they're going and eating. We can see their fun level is decreasing quite rapidly. So we've got different personalities sort of happening there just by setting up those different traits, which is what we wanted. We wanted to be able to give these AIs a bit more of a sense of sort of being sort of different and being different people, and we can do that quite easily. Now, in this case, we're scaling both the score and the impact the same, but we might not want to do that. So we've already got a split for efforts, a decay rate, and then the scale. We kind of need a third split for scoring versus the actual stat change. So what I would do is we're going to have another set of factors here. And then we're going to have, impact scales, and they'll call these scoring scales. So we're going to have impact like that. Now these, if I rename these, I would lose the data. So what I can do is I rename them, but before I save, before I go back to Unity, what I can do is I can go, and this, to be able to access this, I need to bring in unityengine.serialization. So I can do formally serialized as positive scale. So this can be handy if you decide to rename something during development. You can set this up, and then once you've resaved all the data, you don't need those values anymore. You don't need the formally serialized as, but for a little bit during that sort of changeover period, you can keep those in. So that's good. Well, now we need to know, we've got now a third thing. So I wouldn't, chuck in another Boolean. What I would actually do is, this is sort of telling us what change type we're trying to actually, or the target type. So I think I would have a target type, and this will be, I'll set up an enum actually here. Public enum e target type, and then we can have score, impact, and decay rate that way. And we'll actually put this, I think, down in the trait, just because I want it to be not fully out in the public sort of global space. I think I'll set it up here like this. And then we have, when we're going to do the apply, we have to provide a trait eTarget type. And I'm going to actually put this early on there. We lose decay, and this then becomes, okay, is our target type, and we can check decay rate. Then we'll have F, our target type is impact, and then finally we can just default to it affecting the scoring. So scoring and the other ones are going to be largely the same. So that looks good. We'll fix up the little errors in a moment. But if it's impact, then these become impact underscore. Otherwise, they become scoring. Now we do need to feed then this target type through, and that's okay. That's quite easy to feed through wherever we need it, because we lose the decay rate, so that's staying pretty straightforward. And the compiler will helpfully flag any of the areas where we know we need to go and fix this up. So we know Common AI Base has that apply stats or apply traits to function. So we know it has to be updated. So we just go through each particular one, updating it. And then these become a lot easier. We get rid of the trues. And the advantage with the enum is if we need to add in further ones, it's now even easier for doing that. So so this becomes trait eTarget type, decay rate. So we just pass that through for all of these. Now, applying individual stats, this is actually doing a scoring change. This is actually doing an impact change, sorry. So that becomes like that. And then our simple interaction was doing scoring. So with our the not so simple AI was doing the scoring. So that changes here to, this is scoring the change. So that becomes score. So now the impacts can stay the same, but the scores can be affected. So we can see we've got the particular ones there. So by default, the impact is now actually going to be unchanged, but the way it scores things will be different. So again, you could have an AI that it might score things the same, but the impact is very different. So it gives us a lot of flexibility over how this is going to work. So like our easily bored one, the negatives we've really scaled up, the decay rate we really scaled up. Our easily entertained one, they get a lot of energy really quickly, and so that looks pretty good. So if we run it, we should see largely no difference visibly from what we saw before, because we've set those impacts to be the same. So the bars will go up and change slower, but the way the AI is scoring things is differently. So we can see energy went up a chunk, but it's still this AI that is easily bored is going to tend, and we can see they're prioritizing things that are fun. So they are generally, whereas this other one is sort of keeping a little bit more balanced, the one that's easily bored is going to let themselves get pretty hungry before they decide to go and eat. Like even at this point, that bar is getting pretty low. It's probably at about 25%. And they're still like, nope, want to have fun, going to read a book. And it will take it getting to be quite serious for them to actually prioritize. And there we go. Now there's enough of a score of doing something that's not fun for them to actually have an impact. And we could start to do further things where particular, devices, particular things might have different impacts for different AIs. So there's things like if that we could start to classify activities, and those activities also feed into those traits. So this is something that can make a really big difference. And the AIs before they were sitting fairly similar with their bars, but now that personality is coming through. So this is something you could add further to. So you could be setting up other different personality traits with the way we've designed the personality system. It's quite easy for the AIs to add in extra ones to customize how those impact on things. And that's something that gives us a lot of sort of things to work with for making these feel like actual different sort of living characters that have a different personality and different reactions to things. So dive on in and experiment with it, see the kinds of things that you can add to this as well, and see the kinds of personalities that you can have these different characters actually demonstrate. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out, it's really appreciated. If you're looking for the code for the project, that is available up on GitHub, and there is a link to that in the description below. You can freely use the code for any of your own projects, commercial, non-commercial ones. There's also a link in the description to a video archive. So if you're looking for videos on a particular topic, things like that, there's a searchable archive there that you can look for videos in. And if you've got any questions, chuck in a comment. And if you're looking for other ways to support the channel, I do have a Patreon, and there's a link to that in the description below as well. But until next time, bye.